Hello everyone, welcome back to my YouTube channel. I am Lavanya SA from Sri Venkateshwara College of Engineering, Vidyanagar, Bangalore, Department of Electronics and Communication. Today in this video I am going to discuss about floating point representation IEEE standards. This topic comes under computer organization and architecture. Here is our introduction to floating point representation. Floating point representation is a method for encoding real numbers in a way that can accommodate a wide range of values. It uses a scientific notation like format. In format, there are different types: sign bit, exponents, fractioning. These are some types of types of formats where we use in floating point. We use some others like single precision, double precision. We in this video I'm going to discuss about single precision and double precision. In single precision there are 32 bits, 1 bit single and 8 bits exponents and 23 bits fractions. Double precision has a 64 bits. In this 64 we have 1 bit sign, 11 bit exponents, 52 bits fraction. It provides trade-offs between precision and range but is subject to rounding error and precision loss. It allows for the representation of very large and very small numbers, making it essential for scientific computation. computation. Understanding floating point representation is crucial for programmers and engineers to ensure accuracy in calculation. Our next topic is the need for floating point representation. Floating point representation is needed for handle real numbers efficiency in computer. The very key reason is, as I said, to handle a large to represent and handle the very large and small number unlike fixed points representation. The second reason is dynamic precision. Precision adjusts based on a magnitude of the numbers, enabling compact storage. And the other reasons are scientific computation, efficiency, standardization. These are the very few reasons for floating point representation. Floating point provides a means to represent a fractional values and very large number. This representation helps in balancing precision range in which vital for many applications. Components of floating point numbers. The components of floating point representations are sign, exponents, fraction. These are the few components of a floating point numbers. A floating point number is a typical composed of three parts as a set, sign, components and fractions. This indicates whether the number is positive or negative, while the exponents determine the scales of the numbers. The fraction represents the significant digits of the numbers, allowing for a precision in representations. In the next topic, I will be explaining about in the next topic I'll give an example for a components of a floating point numbers. This is the example which I have set for a component floating point. IEEE 754 standard overview. The IEEE 754 standard is most widely used standard for floating point computation. It defines format for representing floating point number including single and double precision. This standard ensures consistency and portability across different computing systems and platforms. Single precision format. The IEEE 754 single precision format has 32 bits representing floating point numbers the with the sign exponents and fractions. There are some special cases like 0, infinity and demoralization numbers. These are some special cases. Single precision uses 32 bits to representing a floating point numbers. It consists of 1 bit for the sign, 8 bits for the exponents and 23 bits for the mantissa. As I have said in the starting of the topic, sign consists of 1, 8 bits of exponents and 23 bits of fractions. This format can represent number roughly in the range of 1.18 into 10 to the power of minus 38 to 3.4 into 10 to the power of 38. We have learnt about single precision format. Now let us know about double precision format. Let me take a same example. The IEEE 754 double precision format has 64 bits representing to represent the floating point number with a greater precision and the range than single precision. In the same structure, we have sign bit has 1 and exponents as 11 bits and 52 bits for mantissa. Um, in the double precision format also there are some special cases 0, infinity, nan and demoralization numbers. This format can represent number approximately in the range of 2.23 into 10 to the power of minus 308 to 1.79 into 10 to the power of 308. Rounding in floating point arithmetic. Rounding is necessary in floating point arithmetic to manage precision limits. The IEEE 754 standard specifies several rounding modes including round to round to nearest or round towards zero. Proper rounding is crucial to minimize error in calculation and maintain numerical stability. Now let us know what are the limitations of floating point representation. Now let us know what are the limitations of floating point representation. Floating point representation can lead to precision loss due to rounding error. Precision loss occurs because not all the real numbers can be represented exactly. It may also suffer a representation error, especially with the number that cannot be precisely represented. Limited numbers of a bits restricted accuracy leading to the truncation. Overflow. Extreme large or small can exceed the representable range. Complexity. Floating point arithmetically is more computationally intensive than integer operation. Representation gaps. Uneven spacing between representable number increasing with a large magnitude. And some these are the few limitations and some of the limitations, and understanding this limitation is essential for developing mitigate issue is numerical computation. It may also suffer for representation error, especially with the number that cannot be precisely represented. Now we have learned about limitation. Let us see where we apply. Floating point representation is widely used in scientific computing, simulating, graphing, and scientific computing, graphing, and gaming. machine learning, financial calculation, single process, embedded system, weather forecasting. These are the few applications where we use in floating point representation. And whereas embedded floating point representation is widely used in specific computing, stimulating, and graphicing, gaming, financial calculation, machine learning, signal processing, embedded system, weather forecasting. These are the applications where application float point is used. I have said here financial calculation, embedded system, machine learning, and scientific computing, graphing, and gaming. But where do we apply this? Scientific computing is applied in solving equations, simulation, and modeling in physics, chemistry, and engineering. Whereas graphing and gaming is used in 3D graphing and handling the transformation with the precision. Machine learning. Machine learning training and developing AI models, examples robot or some other model AI machines tools. Machine floating point is used. I have said here financial calculation. In financial calculation, floating point is used as to represent the currency value and interest rate with the fractional precision. Embedded system which we use which is very useful for us in the future. It is floating point is used as a real time control system, for example in robotic and aviation. Weather forecasting. In weather forecasting, it is solving a complex number models for climax and meteorology. Many programming language and hardware architectures support floating point operation based on the IEEE 754 standards. And the final conclusion of floating point representation is it is a fundamental concept in the computer science and engineering. IEEE stands IEEE 754 stands provides a framework for consistency floating point calculation across platform. A solid understanding of this concept is vital for efficiency, effective programming and accurate numerical analysis. For the reference, I prefer for the further information I prefer IEEE standard for a floating point arithmetic and author by David Goldberg. Whatever computer scientist should know about floating point arithmetic, and another author by William Kahn, the mathematics of a floating point. Thank you all for watching my video. I hope this video was very helpful for you all. For the further information, as I refer the books, please go through it and collect the information which is very important for you all guys. And see you all guys with the next video. But before leaving the video, I request you all guys to please share, like, and subscribe my video. It helps a lot for my academics. Thank you all. See you in the next video.